Okay guys, I'm going to try something I've never done before, and that's make a video of a concept we're doing in class. One of the skills that we all need to know is how to take vectors that are in 2 dimensions and then add them up. So what I want to do today in this video is kind of walk through an example of how to do this and kind of maybe show some pointers kind of while we're looking at it. Okay, so we're going to start out with 2 vectors. Like I said, these are going to be in 2 dimensions. Our first vector, let's say our first vector is 40 meters at 32 degrees. Okay, and we're going to add that vector to a second one, which is 20 meters at, and let's just say, I don't know, 170 degrees. Okay. And this process that we're doing, it'd be the same whether it was 2 vectors, 3 vectors, or 232 vectors. It doesn't matter. It's all the same process. So what we want to do is basically, I recommend sketching them out. And it's not completely necessary to sketch them out. Some people like to do it, but ultimately it's not entirely necessary to do it. But it does help. So I'm going to just kind of do a quick sketch of this vector. I'm going to say that's about 32 degrees. Once again, this is a complete guess because it's just a sketch. Right? I'm going to take that vector and then sketch the second one. Okay? And it's about 170 degrees. So let's say it's about something like that. Okay? So 20 meters. And that angle right there is our 170. Okay? Alright, so now we got a sketch, and it looks like our resultant is going to be this little yellow line right here, and this is really what we're trying to solve. We're trying to solve the length of that yellow line and the angle of that yellow line. Okay, so I want to go through the process of doing that, and a lot of times, students do find this kind of confusing. So that's really why I wanted to make my first ever video about this particular topic. Okay, so I do it a very methodical way, and if you go to 3 or 4 different physics teachers, you'll get 3 or 4 different ways of doing this. For me personally, it's the way I found best to do it, and that's called what I call doing it the component method. I'm not sure what the actual name of it is, but that's what I am going to call it. Okay. So to do the component method, the first thing you need to do is make sure your vectors are in vector notation, and we've got that right there, so we're good to go. That's in vector notation, that's in vector notation. After you've done that, then what I recommend doing is making a chart. Okay. So on this chart, we're going to have all of the x components on this side. I'll call that the x component side. And I'm going to call this side the y component side. Okay. And what we're going to do is we're going to go through a process of breaking these 2 vectors into each of their x components and y components, and then place them on this chart. Okay. So to do that, here's what we do. And the reason why I like everything being in vector notation so much is that little at symbol, you can kind of think of it as being replaced. On the x component side, we're going to replace that at symbol with the word cosine. So case in point, here's what we're talking about. So instead of doing 40 meters at 32 degrees, I'm going to do 40 meters times the cosine of 32 degrees. Okay? And I'm going to do the same thing with the 20 meter vector. I'm going to do 20 meters at the cosine of 170 degrees. Okay. All right. Because ultimately what we're going to do is we're going to add whatever those come out to mathematically together to get our components of our yellow lined triangle over here. It's kind of hard to see that triangle right now, but imagine that the x components are going to be this blue line. Because when I add these 2 together, I'm going to get the length of whatever that blue line is. Right? When I add the components of the y together, I'm going to get whatever that line is right there. Okay, so we've done part of the chart. Now we're going to do the other part of the chart. And the other part of the chart is we're going to do the exact same process, except this time we're going to put in sine. Right? So watch. So 40 meters times the sine of 32 degrees. Right? And then 20 meters times the cosine of 170 degrees. Okay? And we're going to add those up too. So now I'm going to pull out my little handy dandy calculator, which I hope is working because I had to actually use one on the internet. So we'll see how that goes. Okay. So 40 times the cosine of 32 equals, we'll say 33.9. So that component comes out to 33.9. That's how long it is. Okay. We'll do the same thing with the 20. Okay. 20 times the cosine of 170. And that equals negative 19.696, but let's just keep it easy and round to the tenths place. So we'll be consistent that way. So negative 19.7 is what that comes out to. Okay. And since I've already got the calculator here, I'm going to go ahead and do the components on this other side right here. Okay. Go and do the math on those as well. Okay. So I'm going to do 40 times the sine of 32. And that comes out to 21.2. So 21.2 is that component. Okay, and now in the calculator I'm going to do 20 times, I just noticed a mistake. Sorry about that. Okay, once again, these videos are not going to be edited because I don't know how to do that. So I'm human, so instead of writing cosine right there, that should be the word sine. I caught it before I typed it in the calculator, so it should be 20 times the sine of 170, and that equals 3.5. Okay, so now I've got these two components. I'm going to add them up. So I've got 33.9 plus negative 19.7. So I'm going to type that in my calculator over here. So 33.9, well, let's just say minus 19.7. And that equals 14.2. Okay? So 14.2. I'm going to need that number.
Please come to the main office. Please come to the main office.
Once again, these videos are not edited. I do one take and one take only, so sometimes there may be some disruptions, like intercoms. Okay. All right, so next component, next side, should be 21.2 plus 3.5. And that equals a good old 24.7. So 24.7. All right. So basically what I've just done is I figured out that my red line over here, that red line is 24.7 long. Okay. I could label it, but I don't want to. And the blue line over here is 14.2 long. So what I've done basically is I have made a triangle, and I'll sketch this out just to kind of show you what's going on here. That has a yellow line that I still don't know the length of, but guess what? I know the length of two of the sides of that triangle. Okay, so that's something for trig. Okay, so I know that that blue line is 14.2 and that red line is 24.7, and I don't know the hypotenuse, but guess what else I do know? I know that that first vector, that first one I had, well, never mind, it doesn't even matter. I don't even need that angle, because guess why? I can do the Pythagorean theorem. So I can do the Pythagorean theorem to get the length of that yellow line. Awesome, huh? Well, our Pythagorean theorem in physics looks a little bit different than the one you're probably used to in math. Okay, but it's the same concept. Instead of saying a squared plus b squared equals c squared, I'm going to do something slightly different. And if I sit in here too long, the lights do go off, so that's why the video changed real quick. So I got to get up and do some calisthenics real quick to make the lights turn back on. There we go. All right. Okay, so where were we? Oh, yes. Pythagorean theorem. So my Pythagorean theorem is going to be the sum of the x's, and guess what? The sum is what we've got right there, 14.2 squared, plus the sum of the y's squared is going to equal my resultant squared. Okay, Pythagorean theorem, right? That's my a squared, that's my b squared, that's my c squared. Okay, so I'm going to go ahead and plug in my numbers. So I'm going to say 14.2 squared plus 24.7 squared, and I'm going to go ahead and do the square root now. Should equal the magnitude of my resultant.
Saul Gardiner, please come to the main office. Saul Gardiner, please come to the main office.
They like the intercom today. Okay, so 14.2 squared is 201.64. So 201.64 plus 24.7 squared equals 610.1, we'll round, squared. Oops, sorry, no square there. But we're going to add them up and then do the square root. So here we go. 610.1 plus 201.64 equals a really big number. Well, not that big, I guess. 811.74. I'm not going to round yet because I'm about to do the square root right now. So I'm going to do the square root of that answer, and I get 28.5. So 28.5 meters is the length of that particular vector. Now, a vector has to have both magnitude and direction, so we're not quite done yet, but we're awfully close. Right? Now, what I've just determined basically by using Pythagorean theorem is that this yellow line right here is 28.5 meters long. Okay? So that's basically how far we are from where we started, way back over here in that very first place we left from on this little journey. Okay? To get the angle, here's the way I like to have the angle done, and other people, like I said, are going to have different ways of doing this. Okay? The way you do the angle is you do the tangent inverse of the sum of the y's over the sum of the x's. And by y's and x's, I'm talking about the components, the y and x components. Okay? So for us, I didn't do that very well. Should be theta equals the tangent inverse of sum of the y's over sum of the x's. Okay? So here's what it's going to look like for us. Tangent inverse of, let's see, lost my place here. Sum of 24.7 divided by 14.2. Okay? So the tangent inverse. Okay, my calculator doesn't like to do the tangent inverse, so I'm going to try to find another one here real quick. Once again, this is not edited video. Okay, so here we go. All right, I'm going to do the tangent inverse of 24.7 divided by 14.2. Okay, and if this calculator is working right, waiting for the answer. Waiting for the answer. Still waiting. Waiting for the answer. Okay. I'm giving up on this calculator. I'm going to a different website. Once again, One Take Tommy. That's my name. Okay. Inverse tangent calculator. Math.com. It's got to be good, right? It's called math. Okay. I'm going to find the inverse tangent of 24.7 divided by 14.2. Okay. All right. Now, if this is working out right, it gives me a good old angle of 60.1 degrees. So here is going to be my final answer. Okay. My final answer is going to be 28.5 meters at 60.1 degrees. Okay. And what that has told me then is that basically this vector right here, this vector is 28.5 long, and the angle of that vector with respect to the x-axis is 60.1 degrees. Okay, so that's kind of the process of doing the component method. I hope you like this video. If you like it, I'll be happy to do more of them. It is kind of weird talking to an empty class, but hey, that's my problem, not yours. This is Mr. Smith. Once again, if you have any questions, let me know. See you guys soon. Bye-bye.